Okay, so this is a quick tutorial about the question in your assessment. Close this. So the question says a sample of fertilizer was known to contain ammonium sulfate and sand. At 2.96 grams of the sample was heated with 40 centimeter cubes of sodium hydroxide. So basically, in order to treat the sample, this is the requirement, you seem to have to react it with sodium hydroxide. So this is your sample, and this is sodium hydroxide. Okay, and then so you added sodium hydroxide in excess, and all the ammonia produced from this reaction, it boiled away, it was evaporated. After cooling, the remaining sodium hydroxide, so this amount of sodium hydroxide was reduced, so some of it was has remained basically, and that was neutralized by 29.5 centimeter cube of 2 molar of HCl. So whatever left behind, let's say here, you use you use basically the HCl to titrate it against sodium hydroxide. And if you know the amount of sodium hydroxide, then subsequently you will know the amount of ammonium sulfate. So this is the first experiment. Second experiment, in a separate experiment, 40 centimeter cube of the original sodium hydroxide, maybe from the same bottle, from same volumetric flask, 40 centimeter cubes of the original sodium hydroxide, similar to this sodium hydroxide, was exactly neutralized by this amount of HCl, which has the same strength of 2 molar. So to start with, they want you to write the sodium hydroxide HCl reaction and ammonium sulfate and sodium hydroxide. Now, I hope that you have made the connection between the two, because basically you do this reaction, and after you do this reaction, you neutralize the remaining sodium hydroxide with HCl. So this is an easy one. So basically, this is HCl plus sodium hydroxide. It gives the sodium chloride and water. So that is 1-to-1. It's a balanced equation. And now when you react these two, plus sodium hydroxide that will give ammonia, water, and sodium sulfate. Sodium sulfate. Plus H2O. The second equation isn't balanced. So basically, if you add 2 here, if you add 2 here, and if you add 2 here. Okay, so here we have 8, 10 hydrogens. Here we have 8, 10 hydrogens. Sodiums are okay, and sulfur is okay. The next requirement and delete this. Okay. So now we know the ratio between the ammonium sulfate and sodium hydroxide is 1-to-2. I had to delete that. Okay, so calculate the amount in mole of sodium hydroxide present in 40 ml or centimeter cube of original sodium hydroxide that was neutralized by the 39.2 centimeter cube of 2 molar of hydrochloric acid. Now, this is basically the 40 ml or 40 centimeter cube it hasn't reacted with anything. This is only sodium hydroxide as it is. So we want to calculate the number of moles. So since the number of moles in this case, since the number of moles according to the first equation is 1 to 1, sodium hydroxide to hydrochloric acid, then basically we have 39.2 divided by 1,000 to convert it to, so this is the number of moles, 32.2 divided by 1,000 times the concentration, which is 2. And the answer I've got here, 0.078. Fine. So I will keep these values because it seems that we have to delete this every time. Okay, so that was the first value. Of course, you have to write the limit. Okay, so this value basically, it's not the one reacted, it's just the sodium hydroxide as it is. It was titrated against the sodium, against the hydrochloric acid, which is 2 molar. Good. The second requirement use your answer, this one, yeah. Calculate the amount in mole of sodium hydroxide present in 40 ml of sodium hydroxide that remained after boiling the sodium sulfate. So basically, this is when you got your sodium sulfate to react with the ammonium. This is when you got the sodium hydroxide to react with the ammonium sulfate to produce the ammonia and the sodium sulfate and water. So this is the information related to this one, which is the 29, the number of moles equals to 29.5 divided by 1,000 times 2. So this basically will give you 0.059. So in the first one here we got 0.078, and here we got 0.059. Fine. So basically, this is the sodium hydroxide, 40 ml sodium hydroxide as it says, and here it's just sodium hydroxide that had reacted with the ammonium sulfate. Use your answers 2 and 3 to calculate the amount in moles of sodium hydroxide that reacted with the ammonium sulfate. Now, this is the one without any reaction. This is the one when it reacted. So the amount that has reacted with sodium sulfate, it will be 0.078 minus 0.059. Okay, so the amount here, it will be 0.019. Okay. So this is basically the amount of the sodium sulfate, of the sodium hydroxide, sorry, that had reacted with the sodium sulfate. So this is the number of moles. The second requirement here, let me just clear this. The second requirement, use your answers to calculate the amount of moles. Okay, we did this. Hence, calculate the mass of the ammonium sulfate. Okay. So to calculate this, basically we have the number of moles of the sodium hydroxide that had reacted with the ammonium sulfate. And also we know that, just get the pen. Yeah, we know from the equation that sodium hydroxide to ammonium sulfate is in the ratio of 2 to 1. This is sodium hydroxide. And this is the ammonium sulfate. Fine. And we have the number of moles of sodium hydroxide that had reacted completely with the ammonium sulfate. And the amount that was basically 0.019. But according to this ratio, the amount of ammonium sulfate is half of the amount of sodium. So that's why we have to divide by 2. Because this amount here, it belongs to the sodium. So the sodium, basically the amount of sodium reacted with the ammonium sulfate is 0.019. So according to this ratio here, it's 2 to 1. That means the number of moles of ammonium sulfate is 0.019 divided by 2. So this is the number of moles of ammonium sulfate. So if we want to find out the mass, then basically you have to find out the molar mass, because this number of moles, if you multiply the number of moles times the molar mass, which is here grams per mole. So mole will go with mole and you will be getting grams. So this number here times the molar mass or formula mass of the ammonium sulfate, which is 132.1. So this will give you a number of 1.25. Okay. So this is the amount of sulfur we have. Ammonium sulfate, sorry. Then calculate the mass that reacted. We did that already. So this calculation belongs to the number of moles, and this calculation here belongs to this part. Okay, finally, they want basically percentage by mass. So the total, if you remember, the total amount of the sample, it was 2.86, I believe. And this is the ammonium that you've got from that sample. So you will basically divide this by that to see how much ammonium have you got in your sample. So just to get the right figure there, just to double check the yeah, so the sample is 2.96. So the answer is, here you have 2.96. 1.96, and here we have 1.25 times 100. So that is 1.25 divided by 2.96 times 100. So it is basically 42.5. Write your answer a suitable number of significant figures. So basically you can say 42.6. In this case, you can round it up. And that's it. I hope it was useful, and I'll see you next time.